Hey everyone, welcome to Code Harmony. Today we are going to cover a very important array question, majority element, and this is a very frequently asked question in all the good companies and in the Google itself. For the last 3 months it has been asked more than 15 times. Before we move further, let me tell you that most of the people start the preparation using array, and array does not have a lot of concept. So most of the problems based out of array are tricky, or sometimes they involve a tactic or a predefined set of algorithms. So we have to cover all of these important algorithms to be able to do very well in the interviews. The similar kind of algorithm we saw in our previous video, which is cadence algorithm, that is also another important problem, and this time we are going to cover another good algorithm which is called Boyer-Moore voting algorithm. Let's get started with the problem statement. Before that, let me share my notepad. Here the problem is majority element, which is LeetCode 169. In this problem we will be given an array nums of size n, and we have to return the majority element. What is a majority element? The element which is appearing more than n by 2 times. Let's say if we are given an array of size 10, if any element is appearing more than 5 times, 6 or more, then that element can be a majority element. So if we have a look on this example, what is the majority element? 2 is occurring 4 times, 1 is occurring 3 times, and the n is 7. So 4 is greater than 7 by 2. So 2 can be the answer. Can 1 be the answer? No. 3 is not greater than 7 by 2. So 1 cannot be the answer, and 2 is the only candidate. So we are going to return 2 from the function. Okay, the problem statement is clear to you, and let me ask you one question. How many number of majority element can we have? If the array size is n and the majority element is appearing more than n by 2 times, it means more than half of the array is acquired by majority element. So there is no scope for another majority element. So we have only one candidate for our answer. And we are also given in the problem statement that we can assume that the majority element definitely exists in the array. It means there is definitely one element which is more than 1 by 2 times. Let's try to have a look on the brute force. How we are going to do that? Well, the one thing can come to our mind is that why don't we just check whether ith element is the majority element or not? Whether the first element is the majority element or not. How do we check? Just count the number of times the majority element coming in the array. Let's say I is 2 and we are at this element. How we are going to do that? We just have to iterate over the array again. So for every I in the array, we have to go n times to see whether that is a majority element or not. So in that case, the time will go quadratic. So in this case, the time will go n square. And this is not a valid solution. We have to think of something better solution. And what can be the better one? Let me think in terms of hash map. What hash map does is it captures the frequency of each element. And I hope you must be aware how do we capture the frequency. We create a hash map, and against every element we will capture how many times it is coming in the array. So if we try to draw the frequency of it, 2 is occurring 4 times, 1 is occurring 3 times. And to capture the frequency, we just have to iterate array only once. So capturing frequency can be done in the order of n time. And from the captured frequency, we will just keep track of the maximum frequency. That we can do in a separate order of n loop, or while capturing the frequency, we can keep track of the maximum frequency captured so far, because that is going to be our candidate. So while calculating frequency, we have been keeping track of the maximum frequency captured so far. Okay, so that is done. So this maximum frequency, we will see whether it is greater than n by 2 or not. That is order of 1 time. So this hash map solution can work in order of n solution. Order of n time. So the time complexity is going to be order of n. but the condition here is that we have to use another hash map data structure that is going to be order of n extra space. Okay, I hope this solution is clear to you. Previously in the brute force it was n square, which was not acceptable. Here we have improved the time complexity from the quadratic to linear, and the linear is acceptable, that is good, but the interviewer is ready to ask you a follow-up question that whether you can solve this question in constant space or not. It means that you don't have to take an extra hash map. This requirement makes this problem very tricky, and now we must know this algorithm, Boyer-Moore voting algorithm. What this algorithm does is, this algorithm is going to help us count the majority element in order of n time, but in a constant space, which is requested by the interviewer in the follow-up question. Now we are going to solve this problem in order of n time, but with constant space. Here we are going to cover Boyer-Moore voting algorithm. The intuition behind this algorithm is that we are going to start with I, and we will consider this ith element as a candidate of our answer. You can say that we have pre-assumed that the ith element is our answer. If ith element is our answer, its count is definitely going to be greater than n by 2. So let's say here, for this subarray, if we consider subarray with only one element, the count of 2 is 1. For this subarray, count of 2 is 2. For this subarray, we will just reduce the count. We'll make the count to 1. So the intuition is that if ith element is equal to the candidate, we'll just increment the count. Otherwise, we will decrement the count. Why we are doing so? Let's say we have chosen our candidate as 2. So in the first subarray, the count was 1. In this subarray, count was 2. In this subarray, count was again 1. And now in this subarray, count has become 0. Now the count has become 0. When the count is 0, it means that this element is occurring exactly n by 2 times in this subarray, because +1 +1 -1 -1. But our candidate should always be greater than n by 2, not equal to n by 2. It means that our candidate is not fulfilling our condition. What we are going to do here is, we will try to update our candidate. Initially, I assume that this is my candidate, and I work on this array, and this array as well, and this array till 1. Okay, but at this moment I realize that the count has become 0, because when it is equal to candidate, count is increasing. When it is not equal to candidate, count is decreasing. So after 4 element, I have come to know that its cumulative count is 0. It means that this element is coming n by 2 times, and we cannot move ahead with this element. So what we are going to do is, we will update our candidate. Now let's say if I choose 1 as a candidate. So here again I'm going to do the same thing. For this array, let me write it again. Till this moment I have covered the array, and now I have chosen this as a candidate. For this subarray, the count is 1, that is greater than 0, and that is fine. And till this moment, for this subarray, count has become 0. It means this candidate is not the maximum element in this subarray. So what we are going to do is, we will do the same thing. We will update our candidate. Again, I have updated my candidate to 2. Now let's see what happened. For this subarray, the count is 1. For this subarray, count of candidate is updated to 2. For this subarray, count of candidate is updated to 3. What this is showing is that this 2 element can be the candidate of our answer. It means there might be the possibility that this element is the majority element. And how do we make sure that it is a majority element? Just iterate over the array again and see whether the count of this element is greater than n by 2 or not. Okay, so this was the approach which Boyer's-Moore voting algorithm told us. Now you may wonder that whether this is going to work even when the same the majority element is at the extreme end. Let's consider one case where the majority element something like this: 1 1 1 1 2 2 2. Here we started with the first element and considered it a candidate. Candidate is 1 and the count is 1. Here the count is 1, count is updated to 2, count is updated to 3, count is updated to 4. Okay, now at this subarray till this moment count is updated to 4 minus 1 3, because 2 is not equal to candidate. Now the count is 2, now the count is 1. We did not feel the need of updating our candidate because our candidate count was always greater than 0. And now if we try to see whether our candidate is actually the majority element, that we can know by iterating the loop. Okay, other possibility can be like whether the majority element is at the extreme end. Something like that: 2 2 2 1 1 1 1. Here first element I am considering as a candidate to my answer. So the candidate here is 2 and the count of candidate is 1 for this subarray. For this subarray the count is 2. For this subarray the count is 3 because all are same. Now till this subarray count is reduced to 2. Till this subarray count is reduced to 1. Here count is reduced to 0. If at any moment when the count is reduced to 0, it means that our candidate is not the majority element is in this section. If it is not the majority element in this section, we'll just update our candidate and check for other possibilities. Now when we were at this ith index, we got to know that the count is 0. I will update my candidate. Candidate initially was 2. I'm discarding 2 and considering 1 as the candidate. For this subarray you mean 0 1 2 3 4 5, index 5 to 5, count is 1. From 5 to 6 count is 2. So after processing the array, I have my candidate as 1. I will just check whether my candidate is the majority element or not. Okay, so here how much time did we take? We just captured the candidate initially, and then whenever the count is becoming 0, I am updating the candidate. So this iteration is going to take order of n time. But in our problem, we were given that there definitely is going to be an answer. So we don't have the need to check whether the candidate is actually the majority element. But if it is not given in the problem, if we have to make sure that it is really the majority element, we'll just iterate over the array again in the plus order of n time and get to know that whether it's a majority element. So the space complexity, you're clear about the time complexity, right? And the space complexity is, I did not take any extra space instead of these O1 variables. Okay, so now we have achieved our constant space solution. So whenever in interviewer asks you to reduce the time, just think of this algorithm, Boyer-Moore voting algorithm. Okay, I hope you understood the approach. Let's try to code this problem. If you scroll down the problem, you will see that there is a follow-up question. Could you solve this problem in a linear time and open space? So we are directly going to use the optimized approach, which is the Moore voting algorithm. Here Firstly I'm going to iterate over this array, and I'm keeping track of the count variable. Count is initially 1, and I can initialize the candidate as nums of 0. The first element is my candidate, and currently the count is 1, and I can iterate from further in indexes I less than and I plus plus. N is the length of the array if nums of I is equal to candidate. In that case I'm going to increment the count, else I'm going to decrement the count. After I have updated the count, I will see if at any moment the count has become 0. In this case I'm going to update my candidate. Candidate is nums of I. Current element is the candidate, and the count is 1 because current element is already considered. As it is given in the problem that we can assume that the majority element always exists, I'm just directly going to return my candidate. Otherwise I would have wrote another loop to see whether the frequency is n by 2, crossing n by 2 or not. Running over sample test cases. Okay, so what we have done wrong is that we have started the loop from index equal to 2, but indexes are starting from 0. So second index is 1 actually. I have to start from 1. 0 is already captured. Okay, I've corrected the mistake. Running again. Sample test cases are passed. I'm submitting the problem. It got submitted successfully. Hope you understood the problem. Thank you guys. Bye bye.